we're only 30 minutes away from the break, so don't worry. Good morning, everyone. My name is Andy Shea. I'm from Alibaba Group, and I can testify that Envoy is a fantastic project. We have this in production. And for those people who are wondering, okay, probably you're wondering about two things. One is, why are we having a Java and RPC topic on the infrastructure conference? That's because this is inspired by a real-world use case. Customer is always right. The second part that you might be wondering is, on the original topic, it says Knative, and now it's rolling back to Kubernetes. The reason behind that was Knative right now only supports HTTP and not RPC, so there we go. A little bit introduction. Apache Dubbo is a popular Java RPC framework in China. It was also open sourced by Alibaba over 10 years ago, and it's still going strong. This survey was done like 2 weeks ago, and we are still on the third place. And we have done some work in integrating Dubbo with Envoy, and it has been upstreamed. But that was yesterday's work. We are trying to renovate Dubbo by introducing some cool features, mainly to make it more efficient. And also integrate better with Envoy. So one of the things that's gaining momentum over the last couple of years is called reactive streams. Reactive streams is asynchronous, non-blocking, meaning that it's not going to tie up your CPU resources. But one thing that's unique about reactive streams is that the subscriber can decide when and how much the publisher can send the data. So that's really important. As an e-commerce platform, Alibaba has a lot of pressure. One of the biggest challenges is that we sometimes see servers or the subscribers hanging there, but they're not dead. So the socket is still going, it's still alive. The publisher or the client is going to keep sending traffic. And these requests will go nowhere. It's really hard to debug, it's really hard to recover. With reactive streams, that's going to be solved. So that's the beauty of reactive streams. And the reactive stream framework we choose is called RSocket. R stands for reactive. RSocket is a popular new reactive stream implementation. It has certain advantages. One of them is it defines 4 types of communication models. There's the classic request response model, which is what we are all familiar with. There is the streaming model, where you send a sequence of events. There is a fire and forget model, which is in cases like you're sending data to the logging or you're exposing your matrics. You don't need a response. And there's a channel. Channel means that you have switch the roles between publisher and subscriber. So it's bidirectional. So what is the reason why we're thinking reactive stream is so special that it raises challenges to our auto-scaling mechanisms? So let's take a look at our real-life example. So this is not reactive streaming, but it's reactive system. When we go to the DMV, the workers are going to call us, when he or she is available, right? Disregard of how long the line is waiting outside. See, traditionally, what we are doing in monitoring the subscriber or the working pods is that we're measuring the resources consumptions, right? The CPU, the memory. But that's not enough. That's not enough, because what we are facing is what we want to do is we want to scale based on how long the line is, and then we want to scale based on how long each person process time is, right? So what we want in this case is that not only we want to have CPU and memory, but QPS and response time. So in our company, each and every enterprise solution is required to have these 4 metrics exposed. And that's where we came in, like that's where the request came from. The other team was asking us to help with, to identify how do we measure the QPS and the response time. The challenge is that in the reactive streaming, in the reactive stream implementation, there's nobody keeping track because it's asynchronous, it's non-blocking. So you can't really know, or you can predict or even measure when the packets are coming back and forth, and you shouldn't, because it's going to hinder your performance. So based on that, we are thinking, oh, wait, what happens when we want to scale, when we want to scale our pods, right? So this is our temporary solution, right? It's based on Envoy. We have built counters in Envoy, and basically RSocket provides frame types. These frame types are based on what I just talked about, the different traffic communication models. There's a request, response, right? There is this stream. So in the typical request and response model, it's type 4. So we can build counters in Envoy. And then we're going to use Prometheus irate function to detect a surge or a spike in requests. The reason why we use Prometheus is Envoy is naturally, by default, natively supporting Prometheus, so we don't have to reinvent the wheels. And also, Prometheus does provide enough functions that we can utilize, especially in the case when we try to get the number. So irate is a rate function, but it has shorter intervals. It's better to detect surges or spikes in requests. Does this solution solve the original requirements of getting QPS and response time? No, but we are juggling between performance and features. So these are the two things we are trying to fight. But this does provide us with a mechanism that can better monitor and scale our workloads. And coming back to the original topic about Knative, the reason why we were thinking Knative might be a good candidate is because Knative's scaling mechanism is based on QPS. So all we got to do is provide response time. But then it didn't work out, so too bad. So here is the demo's architecture, which I know it's pretty rough. Pardon me for the rough drawing. So we have a client, we have a server. The client is a web server, basically, listening to clients, customers' HTTP requests. It's going to fire the Dubbo RSocket requests to the RSocket server. And we have Envoy sidecars in front of them. These Envoy sidecars are using our customized images that I'm going to show you the coding in a minute. But what they're going to do is basically do the counters. And then Prometheus is going to scrape those data from Envoy. And HPA, which is Kubernetes horizontal pod autoscaler, is going to get those metrics and scale the RSocket server. That line is missing because I couldn't figure out a good way to say I'm going to scale you. But yeah, so HPA actually is going to scale on the other side. So here is sample code. So for those who are not familiar with the code structures, there's extensions, and you can have adapters on the Envoy. Basically, the extensions is like any other networking, if you're familiar with it. It's similar to any other networking processing architecture that you can plug in your own adapter. So we have this filter written. So here is the definition of the counters based on the frame types. So one good thing about RSocket is you can look at the frame types in the metadata or in the header, so you don't have to decode the whole payload. That saves some time. And then in the real code, once you notice that it is RSocket data, or it is RSocket frame, you're gonna increase the counter number and then put it to stats. And Envoy, like I said, is gonna expose the stats to Prometheus, so Prometheus is gonna pick it up. So that's pretty straightforward. So this diagram is taken from some other projects I'm going to mention at last. This part, the sample HTTP part, you should replace that with our RSocket server. But on the right side, it shows what I just described. The Prometheus is to grab the data from, oops, too fast. It's gonna grab the data metrics from Envoy, and we have a custom metric server that's gonna grab the data from Prometheus, right? But on the left side, it shows the mechanism inside of Kubernetes, which is important to mention, even though we're not at KubeCon yet. So Kubernetes has this controller thing, and it has auto-scaling mechanism, so it's basically, it has the default implementation of core APIs. By default, you can just call scaling without any customization based on your resource, right? But since we are extending it to have a Prometheus adapter, this is customized metrics API extending the core API, and then it's implemented by the custom metrics API server. By the way, this Prometheus customized API server is one of the couple adapters that's written already, implemented already, so we don't have to redo it. And that's another reason why we picked Prometheus as the way to expose the metrics. So now I love this picture. Take a look. And okay. Hopefully we can all see this. So right now we have only two pods. One is client, which is the web server, as I mentioned. The other one is the server, which is going to be processing the requests from the client using RSocket. And if we do a curl on the,
can you make it bigger?
I'm trying to see. Oops. Nope. Somehow it's getting smaller than than before. I guess it has something to do with the resolutions. Let me see. Where do I see the text? Does it help? No, nothing changes. Okay. Well, nothing changes. Why? Okay. Better? Okay, now we're doing it. Thank you, guys. Okay, now let's, okay. So if we do a curl, you're going to see it simply returns a name, but, oh, I forgot this. So this client has, since it's a web server, it's exposing an IP address. And this is the IP address we are curling. So now let's do traffic surge. So this is a nice tool called Hey. We're gonna send 3,000. We're gonna send 3,000 requests to this URL, and we can take a look. Let's do this as well. So we can take a look at this, but before that, let's take a look at the configurations that we've created. So this is a custom API server, the configuration that I wrote, which is going to query Prometheus. So this is the matrix name, type 4 counter, which was done in Envoy and exposed to Prometheus, and we're going to get it. And we name it outgoing. Sorry, I keep saying outsourcing. And the function we're going to use is irate. And in the HPA definition, we're going to create HPA, which is, I guess, tied to your replica set. So the target is RSocket service 1, and we are monitoring this pod on the matrix of outgoing. I have a target value of 10, which is pretty low, but that's going to be surfaced for our demo. We have replica numbers from 1 to 50. I think we wouldn't get that far. So let's take a look at Hey and try to hit. And we can also take a look at what our HPA says. So HPA is getting something, I hope, or not. No, it's going. So it's creating a couple new pods, basically, because our HPA has detected a huge number of surge. By the way, this number is off, so whoever is writing this adapter, this number is way off. If you look at Prometheus GUI, it's not this number at all. And that's how I figured out how many that I need, the 3,000. But basically, it has detected the number of requests, there's a search, and then it's scaling. So if we look at how many we have now, we created one more pod. Okay, only one. When I was doing this at home, it created 4 more, so I don't know what happened. But at least it responded. At least it responded to the surge. Maybe it's because of the network, I don't know. And this part has not finished yet. So definitely it's slow. I don't think I have network. Okay. All right. So now that has finished, and let's take a look. Okay, still 2 going on. So I didn't change the part when it's going to cool off. So by default, I think it's 5 minutes for the HPA to cool down. Like when your traffic stops, it's going to take a while for it to scale down because it doesn't want to do that again, like in a minute or 2. All right, so that's the demo, and here are some credits. So Li Bing is my manager. He is an awesome engineer. He helped me with this RSocket filter and the demo, so hopefully he sees this. These are the projects I referred to when I was trying to figure out how HPA works, because originally I was thinking of Knative. Obviously, these 3 are very good examples, and I think that image I got was from one of them. So also good thanks to them. So that concludes this topic. Do I have time for questions? Yeah. So any questions, comments? Welcome. Yes, please. The solution to scale this is a demo. So it's to raise awareness of the situation when there's reactive streams that's introduced. It does create new challenges. So the matrix we're trying to get is a production requirement. So these are two different things. Yeah. Any other questions? Cool. I guess we are going to. Oh, yes, there's a question. Thank you. I'm sorry, I cannot hear you.
Why did you use frame type as the metric to autoscale? Why did you use frame type as the method for autoscaling?
What type?
Frame type.
Frame type, okay. Because like I said, that's a good question. The question was, why do you use frame type? Because it's a frame type counter. It's not a frame type. The frame type counter is trying to tell you what kind of frames, because in RSocket implementation, it's a multiplex channel, which means that different frames, different types of frames go in the same socket. So you got to distinguish between this from that. And on top of that, the better way, of course, is to have a counter of like each request and then a response, but then it's going to take a lot more resources to implement. So right now, we're simply doing a counter instead of the full like controlling mechanism or monitoring mechanism of collecting all the data. Yeah. Cool. Thank you.